This video is going to cover Unit 17-2. We're going to be talking about systems of equations. And a system of equation is when you have the same number of variables as you do equations in order to solve for where those lines intersect. So we're going to be dealing with two equations and two variables. Now, there's three ways to solve these two equations, two variables. One way is to graph them. Another way is to use the substitution method. And the third way is to use the addition method. We will not be graphing them because graphing them really doesn't pinpoint the exact answer, especially when you have a fraction or a decimal answer. You can't really pinpoint it very well when you graph. So 17.2 is going to cover substitution, and 17.3 is going to cover the addition method. So when we use substitution, let's take a look at the example on page 476. We have x equals 2y, and the other equation is 4x plus 3y equals 15. Now, one equation is already solved for one of the variables. This equation is already solved for x. So if x equals 2y, then I can put whatever x is equal to in for x in the other equation. So if x is equal to 2y, I can write this as 4 times x plus 3y equals 15. Now we have one equation in this, or one variable in this equation, so we can solve for that one variable. We multiply here, we've got 8y plus 3y equals 15. Combine these two equations and we have 11y equals 15. Divide by 11, divide by 11, and we have y is equal to 15 over 11. Now, that's what y is. So if we wanted to solve for x, we have to take this y value and put it back in one of the original equations for y. Now you could put it in here or you can put it in here. To me, it makes more sense to put it in here. So you would say x equals 2 times y, which is 15 over 11. So x equals 30 over 11. And you could write that as an ordered pair, which would be 30 over 11, comma, 15 over 11. So that is the solution. So remember, an ordered pair is when you write x, y in that manner, right there. X is first and then y. And then you graph that on an xy plane. So 1511 and then 3011 for x, somewhere over there. So what we're solving here is where the two lines intersect. So we've got an xy plane here, the two lines come in and they intersect at the solution to those equations. Now let's take a look at sometimes they need a little bit more setup in order to be solved. So let's go to page 478. Take a look at a couple of those. Let's take a look at one that's relatively simple, number 7. So number 7 is x equals y plus 4 and then 3x plus 7y equals a negative 18. Okay, so this one is already solved for x. So wherever x is, I can just put that in right there, just like that. So I will say 3 times x plus 7y equals a negative 18. So I will distribute this. So I will have 3y plus 12 plus 7y equals a negative 18. Combine my like terms, I'll write it up here. I have 10y plus 12 equals a negative 18. So to solve for y, we subtract 12 from both sides. And we've got 10y equals a negative 30. Divide by 10, divide by 10, and I have y is equal to a negative 3. So then I come over here, and I put my negative 3 right there. So x equals negative 3 plus 4, so x will equal 1. So the answer is 1, comma, negative 3. That's the ordered pair right there. Now some of them we need to do a little bit more manipulating than that in order to make it work. Let's take a look at number 24. Okay, 24, we have 6x plus 5y equals 13, and 3x plus 4y equals 14. So we need to make a decision here of which equation do we want to use first, and then what variable do we want to solve for. So let's pick this equation, the second one, and let's solve for x. So I'll write that over here. So what first thing I'm going to do is subtract the 4y. So I will have 3x equals 14 minus 4y. Then I need to divide everything by 3. So we have x is equal to 14 minus 4y divided by 3. So that is what x is equal to. So I've used this equation to find x. Now I've got to substitute it in for this x right here. So 6 times x, which we know to be 14 minus 4y divided by 3 plus 5y equals 13. So now I have to distribute this 6 in. So let's see. First, before I do that, I'm going to do a little simplification here. I can take a 3 out of here and make that a 1, and take a 3 out of here and make that a 2. That makes things much easier. So what I'm going to do now I just have to distribute the 2 in. So 28 minus 8y plus 5y equals 13. So we combine our y's and we get 28 minus 3y equals 13. Subtract 28 from both sides. and I get a negative 3y equals a negative 15. Divide both sides by a negative 3. This becomes a 1. Negative divided by a negative is a positive, so y equals 5. Then we take it and we can pick either one of these two original equations, and we put this 5 in for y, and it doesn't matter which one. Let's go ahead and use the first one. So I've got 6x plus 5 times y equals 13. So 6x plus 25 equals 13. Subtract 25 from both sides. And I have 6x equals a negative 12. Divide by 6. Divide by 6. Negative divided by a positive is a negative. 12 divided by 6 is 2. So my ordered pair solution for that is negative 2, 5. So these two lines, so each of these is a line. You could graph both of them. They match up, or they meet at this point right here, negative 2, 5. And we're using the substitution method.